Energy is the ability or capacity to do work. It is the power that makes things move, change, or happen. Every physical or biological process in the universe involves energy in some form, whether it's motion, heat, light, sound, or electricity. Energy cannot be created or destroyed, it can only change from one form to another. This principle is known as the law of conservation of energy. Forms of energy include kinetic energy, potential energy, thermal energy, chemical energy, electrical energy, light energy, sound energy, and nuclear energy. For example, when you eat food, chemical energy is converted into kinetic energy. A hydroelectric dam converts potential energy into electrical energy. Energy is essential for all activities and processes. Understanding how energy works helps us use it efficiently.
Potential energy is the stored energy in an object due to its position or state. Kinetic energy, on the other hand, is the energy of motion. Potential energy exists when an object is at rest, but capable of moving. Conversely, kinetic energy exists only when the object is in motion. The formula for potential energy is mgh, where m is mass, g is gravity, and h is height. For kinetic energy, the formula is 1 half mv squared, with m representing mass and v for velocity. Consider a stone at the top of a hill. It possesses significant potential energy. As this stone begins to fall, its potential energy transforms, gaining kinetic energy. This transformation continues until it reaches the bottom, where kinetic energy is at its maximum. In simple terms, potential energy is energy ready to act, while kinetic energy is energy in action.
Let's begin by exploring light and nuclear energy, two very important forms of energy. Light, also known as radiant energy, travels as electromagnetic radiation, which allows us to see the world around us. These electromagnetic waves move extremely fast through space. Natural light sources include the sun and the stars. Artificial sources are bulbs and lasers. Light is key for our vision, for photosynthesis in plants, and for generating solar power and in medicine. Nuclear energy, on the other hand, is stored within the nucleus of an atom. It's released either by fission, which is splitting nuclei, or by fusion, which is combining them. Fission typically uses uranium 235, while fusion is what powers the sun using hydrogen. Applications include power generation, medical treatments, scientific research, and even agriculture. Light is renewable and vital for life. Nuclear is powerful and used for electricity. Both follow the law of energy conservation, which says energy transforms but is never lost. Today, we explore chemical and electrical energy, vital forms that power our world. Chemical energy is stored within chemical compounds, potential energy waiting to be released during reactions. When chemical reactions occur, like burning fuel, bonds rearrange, releasing stored energy as heat, light, or force. Key sources include fossil fuels, food, batteries, and wood. This energy is crucial for transportation, cooking, generating electricity, and powering living organisms. Electrical energy is generated by the movement of electric charges through a conductor. The faster electrons move, the more energy is produced, which can be converted into heat, light, or motion. Major sources include power plants, batteries, solar panels, and wind turbines. It powers appliances, machinery, transportation, and global communication. These two forms are related. Batteries convert chemical energy into electrical energy. Energy cannot be created or destroyed, only transformed. Explore thermal energy, a key concept impacting our lives and technological advances. Thermal energy comes from the constant movement of atoms and molecules within any substance. Faster microscopic particle movement means greater thermal energy. Motion correlates with heat generated. All matter's particles move continuously. Increased speed generates more heat within the substance. Energy transfers from hotter objects to colder ones, constantly seeking equilibrium. Conduction transfers heat through direct contact, a phenomenon observed in solid materials. Convection transfers heat through fluid movement, such as circulation seen in boiling water. Radiation transfers heat via electromagnetic waves, needing no medium, like warmth from the sun. Key thermal energy sources include the sun, burning fuels, electrical devices, reactions, and friction. We use thermal energy for cooking, heating homes, and generating power in thermal plants. Understanding thermal energy is crucial for efficient use and appreciating its vital role today. Let's begin by exploring sound and magnetic energy, two fundamental forces actively shaping our world. Sound energy is produced when vibrations travel through a medium like air, water, or solids. Sound cannot travel through a vacuum because it needs a medium to propagate. Vibrating objects create sound waves, and our ears are designed to detect them. Common sound sources include musical instruments, voices, machines, and even thunder. Sound energy is vital for communication, and it provides entertainment for us all. Magnetic energy, on the other hand, is stored within a magnetic field. This energy links the forces of attraction and repulsion between magnetic poles. Magnets generate a magnetic field, and this field relates to electric energy. Sources of magnetic fields include natural magnets, artificial magnets, and electromagnets. Magnetic energy powers electric motors, generators, hard drives, and MRI scanners. Sound is crucial for communication, while magnetic energy drives modern technology today. Elastic energy is stored when an object is stretched or compressed. When the force is removed, it returns to its original shape, releasing energy. Elastic energy is mechanical energy found in rubber bands and springs. Stretching a rubber band stores energy, converting to kinetic energy upon release. The more an elastic object is stretched, the more energy it stores. Elastic energy converts into kinetic energy when a spring releases or sound when a band snaps. This energy is used in clocks, trampolines, and car suspensions. Gravitational energy is the energy an object has because of its height. The higher an object is, the more energy it stores. It converts when it falls. A rock on a hill has energy, turning into kinetic energy as it rolls. Gravitational energy powers hydroelectric plants. Falling water spins turbines. It drives roller coasters, elevators, and holds planets in orbit. Elastic and gravitational energy are potential, stored due to shape or position.